Hello guys, myself HARSHIT Jain, my teammates IQBAL, RAIYAAN and Nitish. Today our topic is particle swarm optimization, a population-based optimization method inspired by swarm behavior. Each particle represents a candidate solution and moves through the search space by learning from its own best position and the best position found by the group. PSO is an optimization method inspired by the birds fluking and fish schooling. It uses a group of particles that moves in a search space. Each particle learns from its own best solution, and particle also learn from the best position found by the whole group. Over time, a particle moves towards the better solution. It is simple to understand and simple to make. It also works with complex non-linear problem. Each particle tries to find a good answer. Particles follows the own best result and also follows the group best result. They keep.
Now, let's look at how PSO actually works. First, we initialize a swarm of particles with random positions and velocities. These positions represent possible solutions and velocity determine how particle moves. Next, each particle evaluates a fitness function based on its current position. This tells us how good the solution is. Each particle remembers its personal best position and the swarm keeps track of global best position found by any particle. Velocities are then updated using two influences. Personal best influence, meaning the particle moved towards its own best solution, and global best influence, meaning it moved towards the swarm's best solution. Using these updated velocities, particle move to the new positions. Now this process of evaluating, updating and moving repeats until we reach the convergence or the maximum number of iterations required. The flowchart shown in the poster represents this exact cycle and the mathematical formula explains the updation process. And the next step.
Like other algorithm, PSO has several advantages as it is very simple to understand and easy to implement as it uses only a few equations, and it requires very few parameters to tune, which even makes it faster to set up compared to other algorithm like genetic algorithm. And it also converges quickly and works well for complex nonlinear problems where gradient based methods fail. And however, PSO has some disadvantages also. It can get stuck in local optima, especially when particles follow the global best too closely, and the performance is sensitive to the choice of parameters like inertia weight and as acceleration constants. It is not guaranteed to find the exact global optima, and sometimes it slows down when approaching the best solution. And the conclusion part will be told by my friend Nitish.
So guys, I'm going to explain you about the applications and conclusion. A PSO can be applied in many places, like in engineering it can be used for parameter tuning in control systems, helps mechanical and structural design problems, and computer science it helps in feature selection in machine learning and in neural network training and hyper parameter optimization. In robotics, we have robot path planning and navigation. It helps robots to avoid obstacles efficiently. And in business, it helps to forecast and decision making problems. And it also works well with multivariable financial models. And conclusion, PSO is powerful because it uses collective learning inspired by nature, and it is simple to implement but effective for complex real world problems. It doesn't require gradient information, making it flexible for many domains. And thank you.